Question number 4. We've got some pipes in a building, and the numbers represent the length in meters of that pipe. Okay, we want to use Dijkstra's algorithm to find the shortest path from A to J, stating the path and its length. Alright, so for Dijkstra's, we always start off where labeling the initial box, so box number 1, and we've travelled 0 to get there. You'll quite often see in the mark scheme that there's a 0 in this box, so if you do want to write it in, you can do, but it's not, you don't lose the mark if you don't put it in. Okay, once you've labelled a box at the top, you then have to do working values for every single box that comes out of that one. So I've got A plus 3 gives me 3 here in this box B. A plus 8 gives me 8 there. And A plus 5 gives me a 5 there. Okay, then what we do is we look for the box that has got the smallest working value that's not currently labelled. The one that we've got for that one is B, because 3 is smaller than 5 and 8. So I'm going to label this box number 2, and its final working value is 3. I've just labelled this box, so I then have to do working values for every box that comes out of it. So I've only got 3 plus 4, which is 7. So put a single line through that 8 and write down 7. Do not completely cross it out, because that 8 is part of your working out. They need that to give you any of the marks for this question. Okay, we now look for the smallest working value in any box, which is the 5. So box number 3, and it's got a final working value of 5. I've got 3 arcs coming out of here, so I need to do 3 working values. 5 plus 7 gives me 12. 5 plus 9 gives me 14. And 5 plus 4 gives me 9. I look for the smallest number, which is going to be the 7 this time. So 4 and 7. There is 2 arcs coming out of there, so I need to label 2 more boxes. I've got 7 plus 10 gives me 17. 7 plus 4 gives me 11, which is smaller than 12, so a single line, replace the 12 with an 11. Next smallest number is the 9, so I label this as a 5 with a 9 at the end of it. Okay, so 9 plus 4 gives me 13, so I get a 13 here. Next smallest number is 11, so this is box number 6, and it's got a final working value of 11. Label all the boxes that come out of that one. Now sneakily make sure that you just sort of go the ones that look slightly backwards as well. So I've got 11 plus 4 gives me 15 here. And that's sort of a common mistake for people to miss that one. 11 plus 13 is 24. And 11 plus 8 is 19. That's not smaller than a 13, so I don't need to write it down. It might appear on some mark schemes, but it's in brackets, which means that you don't have to have it. Next smallest number is 13, so I've got a 7 and a 13. 13 plus 10 is 23, so I'm going to replace that there. Obviously the 13 plus 8 isn't smaller than the 11, so I don't need to worry about that one. Right, and then on to 8 and 15. I've got 15 plus 7 is 22, so single line, make that a 22. Nothing else is any smaller, so I don't need to replace them. And so then finally, box number 9 and 22. We then need to work backwards to get the shortest path, so I'm just going to do that in the blue bit here. Looking at this 22, if I take off the numbers to see which one matches up, like for example 22 take away 10 doesn't equal 13, so this one's definitely not on this. The one that does work, 22 take away 7 gives me 15, so that's on the path. 15 take away 4 gives me 11, so that's on it. 11 take away 4 is 7. 7 take away 4 is 3, and 3 take away 3 is 0, so that is my path there. So the shortest path is A to B to C to F to E to J, and the length of that path is 22, and it was meters, so 22 meters. Okay, that is part A done. On a particular day, Kim needs to check each pipe. A route of minimum length which traverses each pipe at least once and starts and finishes at A needs to be found, okay? So this is now a route inspection problem, because she needs to go, basically walk along every path, go and check every pipe. Because she needs to start and finish at A, it means that we need all of the vertices to be even, okay? At the minute, the ones that aren't even, I've got A, which is odd because there's 3 lines coming out of it. I've got F, because there's 5 coming out of there. I've got E, and I've got J. So the 4 I'm interested in is E, A, E, F, J. So I'm going to write this here. This is part B. A, E, F, and J. Okay, we should always be able to get 3 pairs of pairs to this, okay? So I could have A, E, and F, J. I could have A, F, and E, J. Or I could have A, J, and E, F. what I need to now do is look for the shortest routes between those different ones on there. So starting with A and E, I'm looking for the shortest route between A and E. I can actually use this thing that I've just done here, because from A to E, I know that there is a shortest route of 15, because that's what it was on there. And for that 15, it was coming along, back along that that route there, so it was 15, but I don't need to write down yet, so I know that that's what it was. Sorry, it's totally rambling there. But yes, 15, because that was given to us by Edexcel. Okay, F to J, I can't really do it from this one on here, but to be honest, that one's quite easy to see anyway. In fact, you can do it from that, because F to J, again, it's going to be 11 between that, because the blue lines are always the shortest ones on there. So from F to J is 11, because it's 4 plus 7. So 15 plus 11. All right. A to F is my next one. A to F is 11, because I've got it onto there. And E and J, I want the shortest path between E and J, which is going to be the 7. Again, it's using the blue lines to help us. And lastly, AJ and EF. Well, AJ is 22. And E to F is 4. Okay, add those up. I've got 26, I've got 18, and I've got 26. The smallest one is the 18, so this is the ones I need to repeat. So I'm going to write down the arcs I need to repeat. So I need to repeat, and don't just write AF for this one. This is why you have to say the individual ones that you're going to repeat. So I'm going to repeat A, B, C, F. Repeat A, B, B, C, C, F. So I'm repeating all of those ones, and I'm also repeating, I've lost it now, EJ, and EJ was just direct in between them. Yep, so, and EJ. Is that all the information I want? Let's check out the question. Use an appropriate and find the arcs that need to be traversed twice, make my method and working clear. Excellent, I've done that. Alright, so part C, write down a possible route given its length. Alright, so I decided, I'm just going to draw this up at this one. The ones I was repeating was A to B to C to F and E to F. Okay, so I need to find a route that goes all the way along this. Now I'm going to steal a method that one of you lovely people showed me, and actually number these, because then what it means is you can kind of do it, check you've got all of the lines, and then you can go back and just write the route after. So going along A, B, so 1, and then along there 2. I'm going to go along there next. I tend to go around the outside first, just because I like that better. So 3, 4, 5, 6, 7, 8. Okay, so I've gone along all of the ones that have got numbers on in that order. I'm back at A now, so I'm going to kind of keep going. So 8, 9, 10. I haven't been along there yet, so 11. Could then go up there. 12, 13, 14. I could go down to H. 15. From H to D. 16. From D up to F. 17. From F back to C. 18. And then from C to A. 19 on to there. Okay, so I then just need to write that all down onto my answer bit. So it goes A, B, C, E, J to start with. So that's 1, 2, 3, and 4. It's A, B, C, E, J. This is part C. Is it part C? Yeah, part C. A, B, C, E, J. So that was number 4. And number 5, 6, 7, and 8 is H, G, D, A. So H, G, D, A. Then once I'm at A, I've got 9, 10, 11, 12. So that was B, C, F, E. B, C, F, E. B, C. This is obviously a lot easier if you don't have to keep clicking in between pages, but never mind. Alright, I was at up to 12, so 13 takes me J to F to H to D. So J to F to H to D. J to F to H to D. I don't know why I'm saying that, sorry. To D, so I was at 16, so 17 starting from, so that's F to C to A to finish off with. So then F, C, A, and that is a possible route there. Part C, done. Okay. All the pipes directly attached to B are removed, okay? Kim needs to check all the remaining pipes and may now start at any vertex and finish at any vertex. A route is required that excludes all pipes directly attached to B. Right, so going back to this original diagram, I'm just going to get rid of all of that working out. So I now don't have any pipes connecting to B, so I can get rid of that one and get rid of that one. Okay, so you can now start and finish at any vertex. So that means it doesn't have to start and finish at the same point anymore. So let's identify the vertices that we've got that are still odd now that we've moved those ones. We've still got the J and we've still got F. Everything else is now even. So what that means is if you've only got 2 odd vertices and you're allowed to start and finish at different points, then that works. You just have to start and finish at those 2 different points there. So this is part D. So she is going to start and finish at F and J, because then she doesn't have to repeat any arcs from there. Hang on, I've still got. Why can't I like count odd things? Because E's blatantly still odd as well. Let's try that again, where I can actually like look for odd things. Ignore all of that rubbish that I just said for the last 2 minutes. Anyway, sorry, going back, I've just realised that E's obviously still odd as well. So E is odd, and so I must have another odd one somewhere. 1, 2, 3, 4, 5, and it's C. Brilliant. Okay, so I've now got C, E, F, and J are all odd. All right, so like I was saying before, we still want to have 2 odd vertices because then we're going to start and finish them. So we'll only need to repeat 1 path. Now we've got 2 options here because there's 2 shortest ones. I could either repeat CF because that's only 4, or in green I could repeat EF. Okay. So that once all the different combinations that we've got. So for combination 1, let's go for repeating E to F. So repeat E, F. And because I'm repeating the line between E and F, that means that E and F are no longer odd. The 2 that would be left odd are C and J. So start and finish at C and J. Start, finish at C and J. And then the other combination was the other shortest one, which was the other 4, which was between C and F. So that is repeat C, F, or repeat C, F, which means that we're going to start and finish at the other 2, because they're now going to be odd, which is E and J at E and J. Okay, so like I said, if you're allowed to start and finish at different points, you just need to make sure you've got 2 odd ones, and there your start and finish points on there.